Hello everyone, this is Meysam Mer Avaran. I've been with Ozone Engineering for a year and a half almost, and before that I was with electrical company called Byton, and before that I was almost 5 years with Ford Motor Company. Today I'll have a presentation which would be on turbomachinery. This would be the first YouTube short. We'll have more coming afterwards. A brief introduction. What are we? We are Ozone Engineering. We are the LA channel partner ANSYS in the Bay Area, and we have 17 years of successful operation and more than 1,000 happy clients and customers. What do? We sell ANSYS products. We conduct trainings. We do customer support, and our areas of interest is multi-physics, and also computational fluid dynamics, and also electromagnetics, high frequency and low frequency. We have good amount of expertise on these topics, and we can help you on that. Here is our territory where we are able to sell the product and provide customer support. We have an office in Portland, Oregon. The headquarters is in Sunnyvale, and then we have some stuff in Long Beach, California as well. Here's the list of the ANSYS products we can sell to you. Some are structural, such as mechanical and Elastina, Encode, you know them. And also on the fluid side, we have Fluent, CFX, FENSAP, Forte. On the electronic side, we have high frequency and low frequency, which Maxwell is in the low frequency and HFSS in the high frequency, and a lot more softwares on this category. We have some tools on semiconductors, some on optics, and also on the material side, we have Granta. On embedded software, we have Skate. And on system modeling, we have TwinBuilder and Medini. And also we have a lot of capabilities in multi-physics and modeling new technologies such as digital twin, etc. So as you see, we have a big list of softwares. So no matter what business or what industry you're in, give us a call. We are probably having a tool that can help you and make your product development process faster. The outline of the current presentation will be: first, we'll have an introduction to turbomachinery. Then we'll go over ANSYS legacy tools, which is mostly Vista. Then we'll have an introduction to CF Turbo, which is a new tool which can model fans, pumps, compressors, and also turbines. Turbomachinery or rotating machinery are pretty much everywhere. Whether you have a pump or compressor or anything which is rotating, you have a turbo machine. They have a lot of applications in oil and gas, in defense and aerospace, in automotive, in HVAC, in data centers and IT and hardware, marine, and also chemical processes as well. They have been around for a long time, and ANSYS already has a workflow for modeling such equipment. The legacy way that ANSYS does it mostly is through Vista and BladeGen. That we'll go through that in the next slides. If you are familiar with the Workbench, if you look at all the tools you can bring into Workbench, we have several tools named as Vista, and based on the application, they have different packs. You see, for example, Vista AFD, which is actual fan design. CCD is like centrifugal compressor design. The other one is CCD with CCM is using performance map, and also it goes all the way down till RTD, which is radial turbine design. And Vista TF is for some preliminary CFD at the early stage. That we won't focus on that too much. These tools have the capability that with the minimal amount of data, such as maybe just RPM and volumetric flow rate that we're targeting, and let's say the head rise or pressure increase that we have in mind as a target, it can give you a very basic initial, or sometimes they call it conceptual design for the hydro machine that you're going to design. The way it works that you bring the Vista inside the Workbench. As you see here, you design you decide what kind of tool you're going to design. Let's say here is an impeller, and then you provide the minimal amount of data, as you see here. And after that, it can tell you how the CAD would look like. This is some step-by-step process. Vista itself gives you performance CAD and let's say the Meridian design. We'll go through the definition of all these in the next slides. And then after that, you can pass those data into the BladeGen, and BladeGen can give you the 3D CAD. Here you see, as I started in the previous slide with an impeller, I provided a very minimal amount of data, these couple of information that you see here. And here it gave me the efficiency curve based on the flow, and then also the shape of the, let's say, the cross section, the side cross section, how it would look like. This is mostly based on the 1D design. And then after that, I just pass it by create a new BladeGen, which is another tool that we have inside Workbench. And when you have BladeGen, then it can give you a better approximation of the geometry. Here you see the meridian chart, we see the performance curve, we see the blade shapes, and after that, the most interesting thing is that you would be able to get a 3D CAD out of it. As you know, for 3D CFD, which is the most accurate type you can do at the moment in ANSYS, is that you need to have a 3D CAD as an input. The beauty of Vista and BladeGen is that just by having minimally sufficient information on performance of the device and the target flow rate that, let's say, pressurized that we have in mind, it can give you a acceptable 3D CAD so you can initiate your 3D simulation, mostly CFD. Here's the workflow that they follow. As I mentioned, for initial design, you start with Vista and BladeGen. It creates some initial design or geometry for you, and then you pass it to other ANSYS tools for meshing. You can do the meshing via various tools, but the most recommended are ANSYS Mesh and TurboGrid. TurboGrid is highly specialized for turbomachinery devices, but ANSYS Mesh can be used. It's pretty much generic. Also, on the side, you can use ISEM or Gambit or Triggerit if you're more comfortable with those tools. After meshing, we can easily pass it to CFD solvers or other ANSYS solvers. The best CFD that we have at the moment is CFX for turbomachinery devices. You can do multi-physics like FSI. You can even go back and modify the geometry using Blade Editor or Design Modeler or Space Claim, and go towards like an optimized geometry. But the workflow, as you see, it's Vista, BladeGen, then some meshing tool, and then some CFD tool. CFD tool we can use, as I mentioned, is either Fluent or CFX, but the most popular is CFX. It has even a turbo wizard inside of it that makes things much more convenient and straightforward, and you don't need to go all the detailed steps. You can skip a lot of it using this wizard. These details will be brought up in the next slides, but here just to mention I have brought it. What is CF Turbo? CF Turbo is as a company, it's a new company which started in 2018 in Germany, and then in 2017 they had a branch in New York, and they have been partnered with ANSYS. They do have a very powerful tool for turbomachinery design, and that's very good for conceptual design. They also have some engineering services and product development, like total design of the turbomachinery, which we don't have time to go over that. And the good thing is that after being a partner, you can bring the tool into ANSYS Workbench as an extension, and it's totally accessible. The beauty of CF Turbo is that it's pretty much replacing Vista plus BladeGen, and out of the best efficiency point or BEP of a turbo machine, which is usually the target that you set in the beginning, it gives you a nice 3D CAD on which you can do all kind of 3D analysis such as CFD or FEA or anything else that you're interested in. This is mostly based on very simple, I would say, 1D questions like a Bernoulli and Euler equations and just conservation, but it's very helpful. When you open CFX, this is usually how it looks like. You see you have different options. It can model pumps, fans, compressors, and turbines. So you choose what type of machine you're going to design, and based on that, it has a different settings that you'll be able to use. Here's, for example, some blowers and fans which have been designed from scratch inside CF Turbo. As you see, it has a lot of capability, different types, different geometries can be modeled. And these are the geometries which have been generated pretty much from nothing, just BEP data and very minimal information. Here's another example, which is the compressor and turbines. I think this is a turbocharger of a car, and then this is just a typical compressor with split and normal blades. And this is another type of turbomachinery, which is pumps, which are also extensively used. You see there's different types of pipe pumps here, which has been designed again from the scratch using CF Turbo. Turbomachinery is a big category of devices, and they don't necessarily act the same way. So as you see in this slide, we have at least 14 or even more types of turbomachinery. Based on the flow rate and the energy transmission, each certain type is being recommended for use. And the types, as I mentioned, they're quite large. You have reciprocating pump, positive displacement, gear pump, vanes, scroll compressors, reciprocating compressors, axial compressors, screw compressors, all these types, which are quite complicated. But in turbomachinery, we can just solve these 4 types, which have been shown with the rosette color here. And that's shown as number 8, 9, and 10, which is radial centrifugal pumps, mixed flow centrifugal pumps, axial centrifugal pumps, and radial compressors. So also the tool is very powerful, and these devices are very commonly used in the industry, but we can't solve every type of turbomachinery with CF Turbo. This is another categorization or classification of the turbomachines. They can be radial. That's because the outlet shoots the fluid radially out of the device, or axial, which does it axially, or you can have something in between. The fluid type could be hydraulic or thermic. Hydraulic is where the flow is incompressible, and thermic would be where the fluid is compressible, so that the density is changing. And another way of categorization is based on how you drive or how they get driven. You can have a driven machine, which means that, let's say, like a fan, you put some power into it and you rotate it to create some excessive head or pressure in the liquid or in the fluid. And then the other one is the turbine, which they get the energy from a high energy fluid and then rotate and create work out of it. This was like a brief introduction on CF Turbo and turbomachinery. In the next YouTube, we'll go over different devices and how to design it in the CF Turbo device. Thank you for your attention and have a great day. Bye.